Good morning, students. Let us see Unit 2 solutions. Neat solve problems in the series question 1. Volume occupied by one molecule of water density is 1 gram per centimeter cube is. First option 6.023 10 to the power of minus 23 centimeter cube. 3.0 in 10 to the power of minus 23 centimeter cubed. 5.5 in 10 to the power of minus 23 centimeter cube, 9.0 in 10 to the power of minus 23 centimeter cube. So before say this, here in the question, volume and density is given. So volume density is a relation of triangle formula, mass volume density. So mass, if they ask mass, volume into density is the formula. If it is a volume calculation, means mass by density. If it is a density calculation, mass by volume. So you by heart this triangle formula, relation between mass, volume and density. So density is already given in the question, 1 gram per centimeter cube of water. So density is equal to mass by volume. They are asking what is the volume occupied. So volume means nothing but mass divided by density. So the formula volume equal to mass by density. Mass divided by density is equal to 1 for water. So the value is volume is equal to mass by 1 is equal to mass. So volume equal to mass. So first we will find out what is the mass. 1 mole of water is nothing but Avogadro number of molecule of water. So 18 grams of water. 18 grams means H2O, 2 hydrogen, 1 oxygen. 1 hydrogen atomic weight 1.008. We consider as a 1, like that 2 hydrogen. So 1 into 2, 2. For oxygen 16 atomic weight, 16 into 1, 16. So 2 plus 16 comes to 18. So 18 grams of water is present in Avogadro molecule. Contains a Avogadro number of molecules. So 1 molecule of water contains how many grams? So cross multiplication 18 into 1 by Avogadro number Na. It is nothing but 6.023. We can round up as 6 into 10 to the power of 23. So 18 into 1. This is 18 into 1 divided by this. So we are getting 3. In 6 in 18 3 times. So this 10 to the power of 23 will go to the numerator, it becomes minus 23. So 3 into 10 to the power of minus 23 is the mass. Mass is equal to 3 into 10 to the power of minus 23. We have found that after substituting the density value, volume is equal to mass. So mass is 3 into 10 to the power of minus 23 grams, means volume is equal to 3, same. 3 into 10 to the power of minus 23 centimeter cubed. So our option is 3 into 10 to the power of minus 23 centimeter. The molarity of solution obtained by mixing 750 ml of 0.m HCl with a 250 milliliter of 2 molarity of HCl will be ml is milliliter and m is molarity. So the values are given in all in a molarity m. The relation between volume and molarity. So they are given as same HCl. Here HCl and another also HCl, they are mixed together. So the formula would be M1 V1 plus M2 V2 is equal to M mixing V1 plus V2. So Mn is 0.5 m and the volume is 750 ml. For next thing, acid strength is 2 and volume is 250. So mixing both the volume 750 plus 250, we are getting 1000 ml. So this is 1000 ml. So V mix is equal to this values divided by 1000. So multiplying 0.5 and 750, 375, 2 into 250, 500. So 375 plus 500 is nothing but 875 divided by 1000. So when the 1000 goes up, it becomes water 10 to the power of minus 3. So what the value is 0.875 m. 0.875 m is the answer. So learn this formula. If it is in a same acid, we have to write in this formula mixing together. If it is in a acid and base means we should put a minus subtraction. 20 grams of magnesium carbonate sample decomposes on heating to give carbon dioxide and 8 grams of magnesium oxide. What will be the percentage purity of magnesium carbonate in these samples? So magnesium carbonate decomposes, gives carbon dioxide. The magnesium carbonate weight is 20 grams and magnesium oxide produced, magnesium carbonate on heating produces magnesium oxide and carbon dioxide. So magnesium oxide is 8 grams. So the percentage of purity of magnesium carbonate in this sample. Options they have given 60, 84, 75 and 96. First, write the equation. Magnesium carbonate on heating produces magnesium oxide plus carbon dioxide. First carbon dioxide will produces and magnesium oxide is forms. So in the question itself they have given 20 grams of magnesium carbonate produces 8 grams of magnesium oxide. And molecular weight of magnesium carbonate 84 grams and molecular weight of magnesium oxide is 44 grams. From the formula we should calculate the molecular weight. So formula mass, magnesium atomic weight is 24, carbon 12, oxygen 16, but we have 3 oxygen, 3 into 16, 48, adding we are getting 84 is the molecular weight of magnesium carbonate. And magnesium oxide, the weight of magnesium is 24, oxygen 16, 1 into 16, 16. So 24 plus 16, 40 gram is the magnesium oxide. So these are the molecular weight of magnesium carbonate and magnesium oxide. So 40 grams of magnesium oxide is produced from 84 grams of magnesium carbonate. Then 8 grams of magnesium oxide will be produced. It will be produced from how much? 40 grams of magnesium oxide is produced from 84 grams of magnesium carbonate. In the question they are given 8 grams of magnesium oxide will be produced and how much of the magnesium carbonate. So cross multiplication 8 into 84 divided by 40. 8 grams into 84 grams divided by 40. So 8 and 40, 5 times. So 84 by 5. So in order to remove the fraction of 5 and that is difficult. So for rationalizing the formula, we multiply by 2 and by 2. So we will get a 168 by 10. So it is easy, only 10, keep one decimal. So 16.8 grams. So 16.8 grams of magnesium carbonate. So 8 grams of magnesium carbonate is produced from 16.8 grams of magnesium carbonate. So 20 grams of magnesium carbonate, they have given in the question 20 grams. This is 20 grams. So 20 gram of magnesium carbonate sample is equal to 16.8 grams of magnesium carbonate. Means what would be the percentage of the magnesium carbonate? So cross multiplication percentage is 100. 100 into 16.8 divided by 20 grams of magnesium carbonate given in the question divided by 20. So we are getting 5 into, this 20 in 100 5 times. So 5 into 160, 16.8 is equal to 84%. So our question answer is 84%. Next question. Mole fraction of solute in 1.00 molar aqueous solution. Options are given 0.1770, 0.0177 and 0.0344 and 1.7700. Moles of solute 1.00 molal is equal to 1 mole. They have given the question that is 1 molal. Molal means mole, 1 mole. So 1 mole. Moles of solute is 1 mole. So moles of solvent in aqueous means, aqueous means water. So find out the aqueous water moles. We all know that is 1 kg. I mean 1 kg means 1000 grams. Water molecular weight is 18. So 1000 by 18, 55.55. This is a consistency value. Please by heart the number of moles of water in 1 gram. 1 kg is nothing but 55.55 moles. So mole fraction of the solute they have asked. Moles of solute is 1 and moles of solvent is 55.55. They are asking mole fraction of solute. X2 is equal to N2 divided by N2 plus N1. So what N2 is nothing but solute moles 1 plus solute moles 1 plus solvent 55.55. So when you solve this, we are getting 0.0177. So let us see the working problem. Working out this simplification 1 by 56.5. I mean 0.0177. So the working out just to see x2 is equal to, I mean mole fraction equal to 1 by 56.5. So now I'm going to teach you, I'm easy to learn this method of division. I mean decimal division. This is called decimal division. So 1 is divided by 56.5. How many decimal? Only one decimal is there. So keep 1 0. So make into whole number 5, 6, 5 divided by 10. So in a multiplication, write the reciprocal of these two. So 1 into 10 by 565 is equal to 1 into 10, 10 by 565. So 10 by 565, how to divide? So I have written 565 divided by 10. Write a 565 table. So 565 table is then easy of writing 0, 565 into 0, 0, 565 into 1, 565, 565 into 2, 1130, 565 into 3, 11, 1695, 565 into 4, 2260, 565 into 5, 2825. So just to simplify this, 2 into 5, 10, put here, 6 into 2, 12 plus 1, 13, remaining 1, and 5 into 2, 10 plus 1, 11. Like that, you just write a 560, whatever it is the value here, write from 0 to 9. It's easy for you to find out the decimal division. So here only 10 is there. So 565 will not go in a 10. So keep a 0 point and add 1 0. Even then it is not going 565 to this, because this is already I have said as 10 upon 565. So this 10 upon 565 we should keep a 0.0 and another 0. So now it is a 1000 value. Then just to see where it is 1000, below 1000, it is above 1000 only is this. So below 1000 is only this value. So put a 1 here. So here 1 and 565 after subtraction, 10, 5, here 9, after minus 6, 3, here 9, minus 5, 4. So here like that, you just do this 400, 350. You just see below 4,350 where? Here. Here 4,520. Here this is 3,955. So choose this 7 times. So 565 and 7 times. So put a 7 here. Then write a 3,955. Subtract this. We are getting 395 and add 0. So 395 below 3,950. It is 6 times. So 33,090. So 6 times. You put 6 and write 3390 after subtraction. 5,000, I mean 560, again add 0, then 560. Below 5,600. Below 5,600 is nothing but 9 times. So put 9 times. So like that, just to find out for 4 letters, four letters. It's enough, etc., etc. So our answer is 0. Just write what is percentage. 0.01769. So it is above 5. After 7, it is above 5. Add 1. So you added 1, it becomes a 0.0177 is the answer. 0.0177. We got a 0.0177. So here in this, you are very easy to learn how to work out the decimal division. This is called decimal division. So 565 make into whole number. How many number is there after the point? That is called decimal. Only one decimal. Add, that is 0. Remove this point and add 0, 1 0. So make into whole number. So in order to multiplication, this we should write a reciprocal of this division. So 10 will go to the numerator. 565 will come to the denominator. Then multiply 1 into 10, 10 by 565. Then whatever the answer would be here, you just write a 1 to 9 tables. So easy for you to just put up the answers. In this series, last question, 25.3 gram of sodium carbonate, Na2CO3. Sodium valency is 1, carbonate valency is 2. So interchange Na2CO3 is dissolved in enough water to make 250 ml solution. We are making up adding a 250 ml of water. If sodium carbonate dissociate completely, a molar concentration of Na plus CO3 2 minus ions. That's what I said. It is a +1 valency. This is a 2 minus valency. Here exchanging here Na2CO3 we are getting. So this is cation and this is anion. So respectively. The molar mass of sodium carbonate, adding all the formulas, 106 gram per mole. So here how to find out, for sodium it is a 23, like that 23 into 2, 1 carbon 12, 3 into 16, 48. Adding all those things, we are getting 106. The options are all given in molarity, 0.477. Capital letter M is called molarity, small letter m is molality. This is RITY molarity. So 0.477 m, etc. Double answer question. This is double answer. 2 answers are given here. So let us find out. For molarity, M is equal to N by V. V is the volume. Number of moles are present in the 1 liter of the volume of the solution. So it should be a liter. So what is moles? Number of moles is equal to weight by molecular weight. So here it is a 2, it denoted for solute. 2 for solute. So N2 is equal to W2 divided by M2. Here our solute is sodium carbonate is a solute. So weight of the solvent, solute is 25.3 grams. And molecular weight is 106. 25.3 divided by 106 is equal to 0.2386. So molarity is equal to N by V. N is 0.2386 divided by volume is given as a 250 ml, but volume to be in a liter only. So 250 divided by milliliter to liter, it should be divided by 1000. So 250 divided by 1000. So the 1000 will go to the numerator. So 0.2386 into 1000 divided by 250. So 250 in 1000 4 times. So 4 into 0.2386, you are getting 0.955. So now I am going to solve you this 25.3 divided by 106. You just see the working out this. Even this also it is called as a decimal division. So in this decimal division, 25.3 divided by 106. I told you to make into a whole number, remove this decimal. It's a 1 decimal, add 1 0. So 253 divided by 10, division of 106 by 1. So for multiplication, I told you to write the reciprocal of this. So this we can write it as 253 by 10 into 1 by 106. So what we are getting? 253 into 1, 253, and 106 into 10, 1060, adding 10. The answer is 0.2386. Let us see this. 1060. I mean 1060 and getting 253 divided by 1060. So in 253 is very smaller when compared to this, so put a 0 point. Then add a 10. So we're getting a 2530. I told you to write tables of 1 to 9 of 1060 table. 1060 table very easy. First time 0, second one is 1 time, and 160 into 2 0, and 6 into 2 12, and into 1 2. So like that 9 we have written. So below 2530. Below 2530. Below 2530, where it is? It is above 3000. Below 2550, it's a 2 times. So put a 0.2. So 2 times, and the value is 2120, subtract 4110. So again add a 0. Then again see below 4100. Here it is a 4240. Below one is here 3 times. So write 3 here, and the value is 3180. After subtraction, we are getting 9 to 0, add 0. So below 9, so here the 9540. So below thing is 8 times. So 8480. 8 times you just put here 8480 values. After subtraction, 720, add 0. And below 7200. This is above 7420. So it is this is 6360. Below 7200, 6 times. So we are getting this, etc. 4 letters is enough to you. So make into correction 2386. So 0.2386 is the decimal division value of 25.3 divided by 106. And I have given you this thing is not one answer we found it 0.955 molarity, and here they have said as another question is sodium carbonate Na2CO3 gives 2 Na plus and 1 CO3 minus. So in order to find out the concentration, so it is 0.n55 into 2 and 1 into 0.955. We are getting 0.955 for carbonate and for 1.90 m for a sodium. So what we are getting, carbonate is 1 mole and the sodium is 2 moles. So what we are getting, this multiplying this number of moles, we are getting the double answer. This is for sodium 1.910 and for this is for carbonate 0.95. Same value only you are getting because carbonate is only 1. Sodium is 2. So we are getting this. They are asked first sodium and then carbonate. So first one is sodium, second one is a carbonate. First one is sodium, second one is carbonate. Thank you, students.